Hey, it's me, Destin. Welcome back to Smarter Every Day. In a previous episode of Smarter Every Day, I went to visit my dad and found him repairing a carburetor on his tiller. After he told me how they worked, we went away and made this, a transparent carburetor. You could actually run fuel through this thing, so Dad and I went to the garage. We used a high-speed camera to see through the carburetor, and we could actually see the fuel being atomized as it goes down into the engine. I highly encourage you to go watch that video if you haven't yet, but basically we made the simplest carburetor possible. It has a bowl down here, it has a float, and it has a venturi, and you can see the choke and the throttle here. This thing is technically a carburetor. However, a lot of people pointed out that it's not a real carburetor. There's so much more that goes on in a carburetor to make an engine work, which is why today we are going to look at an actual carburetor. This is a Holley carburetor. We're gonna open this thing up. Check this out. It's got a smell to it. It smells like gas. All right, so let's open this thing. Let's just look at it for a second. Sometimes that's good. I can tell you this right now, there is way more going on with this bad boy than what we've got. We've got a venturi on ours. We've got 4 holes here. It looks like we even have venturis in venturis. Yo dog, heard you like venturis. Okay, a lot happening there. Flip this thing over. Okay, so we got some floppy doos here. So let's turn, okay, look at that. So when we turn this bad boy here, there's a linkage right here. Can you see that? Turn that thing, the linkage moves. 2-stage floppy doo action. That is serious. What else do we have? Oh, look at this. This thing goes all the way across, and there's a rocker arm here. Can you see that? When I operate the floppy doo, look at that. It's squishing something in there. Okay. This is fascinating. There's a lot going on here. The other thing though, I love manufacturing. Like my first 2 big boy jobs were manufacturing jobs. Cannot get enough of manufacturing. So here's what I want to do today. I want to take Dad, who taught me about how carburetors work. I want to take him to the place where they made this, because there's so much going on that we don't understand. Like every little place you see a hole or a screw or machining, that obviously contributes to the operation of the motor vehicle. Otherwise, they wouldn't spend the money to do it. So this is fascinating. So let's go to the plant where they made this. Let's take Dad, let's make it a thing. Let's go on a road trip with my dad. Let's go up to the plant where they made this Holley carburetor. Let's find some smart people, and let's try to get smarter every day about carburetors.
Okay, so got Dad and Mr. Shane Weckerly. You're over engineering, is that true?
No, I'm strategic planning and acquisition stuff.
Strategic planning and acquisition, but he knows all the engineering of this stuff. I've been talking with him a while. What we're about to do is we're going to build a carburetor from the ground up, basically. Is that true?
That's correct.
All right, and we're in Bowling Green, Kentucky, and let's go for it.
Okay. So in your carburetor video, you had a lot of different channels and passages in your little mock-up carburetor.
And that was actually one of the main pieces of negative feedback I got, is a carburetor is very complicated.
It is.
But we simplified it.
You did, and you did a great job of simplifying it. But this is really the brain of a carburetor. So this contains all of the various passages that basically tell the carburetor what it needs for fuel to mix properly with the air. So this would have your idle circuits in it, it would have your mid-range circuits in it, has your main circuits in it, has your idle adjustment needles, and everything is in this one part. So we take, and on our higher end carburetors, they're made out of billet aluminum. So we take a solid block of aluminum, load it into this machine robotically loads it into a CNC mill, and it creates all of the passages and all the internal geometry that's contained within this.
Okay, so you said a few things. You said idle circuit.
Yep.
What else did you say?
So idle circuit, the mid-range circuit or transition circuit, and then the main jets, which is your wide open throttle circuit.
Okay, and show me how I would control those.
You have fuel against this side, and then you've got a gasket on this side, and it creates passages here that the fuel mixes with air and gets discharged into the engine.
Can I see it?
Sure.
So it's, these little channels here are...
They become passages once you put a gasket and pinch that between that and the main body of the carburetor.
So I can imagine the size of that passage, the length of the passage in fluid dynamics head loss and stuff like that matters.
That's correct.
So everything here is precisely engineered.
One of the things that people don't realize is a carburetor just doesn't inject fuel into the motor. It actually atomizes fuel within the channel. So you'll have a mix of air coming in here, you'll have a mix of fuel coming in here, and then it atomizes within this channel before it ever puts it into the motor.
So my video was a little bit misleading. So where I had just fuel coming in, you're talking about there's some pre-atomization, which doesn't mean it turns it to atoms.
Right.
It means
correct.
it just turns it into small droplets.
That's correct.
Okay, cool. I'm with you.
Okay.
So an idle circuit is when I turn the throttle down, that's the circuit that keeps it running.
Correct. So when you're sitting there idling at a stoplight or you know, wherever, that's the circuit that would be running at that time. When you start to accelerate, you've got to add additional fuel through a squirter and the mid-range circuit, and then that starts to transition in. And then as you go to wide open throttle, you would have a main circuit that would feed the wide open throttle characteristics.
And that's all we showed was the main jet.
Yes, correct.
So there's the idle circuit, the transition circuit, and the main jet.
Yep.
So we're making the brain of the circuit here.
Yep. In here you've got a robotic loader, and you can see it's got a bare aluminum block sitting there on one side of the pallet, and then it's got machined ones right next to it. The robot knows which ones it has pulled, which ones it has loaded, which ones it's unloaded.
What's it called?
Bannock, I believe the way you pronounce it.
Bannock, that's a robot?
Yes.
So basically, instead of having a human hit cycle start, you're now having robots hit
That's
cycle
correct.
start.
So this machine runs unattended all day long. Somebody has to load new pallets in it, you know, maybe once a day or a couple of times a day, but other than that, it runs unattended. So what you see here would be an unmachined casting. This one actually has had the first machining op here on the bottom, but it'll get some additional machining after this.
Okay.
We also would have an unmachined base plate.
I'm seeing all these ports and things like that. What's up with that?
Well, a lot of these feed vacuum passages. They'll feed vacuum to different parts of the carburetor. They'll feed different like fuel out of transfer slots that'll be machined in later on.
So my understanding of a carburetor is it's a complex, dynamic environment where like even the size of a passage matters because that affects the flow rate.
Yes, everything matters.
Everything matters.
Everything
So it's a balance, right?
That's correct.
And so we're going to walk through this line and probably can't go into too much detail because it's a dark art, right?
It is.
But let's go for it. Let's build it.
Okay, sounds good.
So the first stop is where the castings of the base plates are being machined down. Machining is when you use hardened tooling to remove excess metal from a part. What plates they're machining here depends on what type of carburetors they're making on any particular day. They fly cut the metal castings down to a certain thickness and then they drill very specific size holes in them.
So the part gets loaded here. There's 2 tables to load parts. Come over here. There's a check position here. Then you go into here and then you go into here, right? They do the same thing. So you have slower operations, and then you got the one finished up. That's a finished part. Thank you very much.
Okay.
So we've got 2 things going. We've got the base plate and the main body.
Correct. Main body goes through a similar type of machining operation, machining the bores, the passages, the venturis.
So that bore has been machined.
Correct.
That's amazing. So you get pretty close on your casting.
We do. We
Okay.
do. We don't have to take a lot of material out of it. This is an example of a fully machined main body. So you can see, been machined on the inside. This one just touched the inside here. It doesn't machine the whole primaries. But you can see you got a lot of different passages and holes. A lot more than your carburetor you built made.
Why is this housing up here like this?
This is where a choke flap would sit. So this is where your choke seals off, and then it opens up once the engine's warmed up.
4 barrels.
Yep.
The choke is only on 2 of them.
That's correct, because all of your slow speed driving is only on the first 2 barrels.
Got
the
it.
other 2 come in when you go to more wide open throttle.
Got it. That makes sense. Does that make sense to you?
Yeah, absolutely.
So I'm going to take you to the start of the assembly line.
Yeah, sounds good. I chase squirrels, and there's too many operations at this plant for me to be trusted to be able to ask whatever question I want.
There's a lot of stuff going on here.
There is. Main body assembly, okay? These are shinier,
These are shinier. These have been through the tumbler.
okay?
So we make carburetors in a lot of different ways. We make them shiny. We make them gold dichromate. We make black ones. Just depends on the finish the consumer's looking for. So this one is ready to go down the main assembly line here. The first operation is it will go in, have some air bleeds put into it, and then it'll start down the line having various components bolted onto it as it works its way down the assembly line. So that's installation of the squirter nozzle. These are 2-barrel carburetors being built here.
These are 2 barrels being built?
2 barrels instead of a 4-barrel.
She installed the what nozzle?
The squirter nozzle. So we talked about that transition circuit. The transition circuit is when you need to put in additional fuel to get to, you know, your intermediate and your high.
When I hit the gas pedal, unlike mine, you can't wait on a main jet. You have to have something ready to go.
You got to have something to squirt in additional fuel. So she installed the squirter that has 2 squirter nozzles that spray out.
And what's happening in this operation?
So this operation here, she's actually putting in what's called the booster. So I'll reach over her here. Where you had the tube that stuck up in your carburetor, this actually is what we call the booster. And it's your tube, but it's this way, and then the fuel comes out the bottom. So she is staking these into the main body so they can't fall out.
Gotcha. And so from here, she does what?
So she's putting in these little, they're called air bleeds.
Uh-huh.
Basically, they are like a jet, but they meter air instead of fuel. When I talked about the air and the fuel have to mix together to emulsify, the air gets metered through that. So we control how much air goes in and how much fuel goes in and how they mix.
So it's a very specific hole.
Yes.
We're starting to create precise orifices.
Correct.
In all of these.
Yep. Drilled holes aren't good enough. You really need machined orifices.
Why are they brass? Why are most of the parts that go in brass?
A lot of it is because the brass doesn't corrode and it can be broached very accurately.
So what's happening here?
She's installing a choke housing. So this is the part that contains a little spring that actually activates the choke open and close depending on the temperature. When the vehicle is cold, it needs richer air-fuel mixtures than when it's warmed up. The choke, when it's cold, closes and lets less air in, which forces more fuel into the engine. That little spring in that housing, as it warms up, it has electric current pass through it. As it warms up, it automatically opens the choke and allows more air into the engine to normalize the air-fuel ratio.
On the one we made,
Yep.
we had a choke that was a flap.
Yep.
Your flap can think on its own.
Correct. That's correct.
That's what we're doing.
That's what you're doing.
There's more than we can talk about here.
You are witnessing the birth of a carburetor. When this number is etched in, it's like naming a new baby, only a carburetor. While this assembly line is running the main body of a 2-barrel carburetor, another line is working on the throttle assembly. I was only able to get footage of them installing the flaps for a 4-barrel carburetor, but you get the idea. My favorite part of this whole process is when they use threaded fasteners to position the flaps in place, and then they mechanically deform the screws so they can't be removed. They're squishing it. It's almost like they're using machine screws like rivets. The sub-assemblies from both of these 2 assembly lines will eventually merge, creating the entire carburetor.
All right, so what's going on here?
Okay, so you're getting down to a point now where the fuel bowls are starting to come in.
Okay, so we've done the Venturi, we've started doing the choke stuff.
Yep, next thing is the metering block and the fuel bowl, which will go onto this assembly.
Okay.
So this piece here goes in.
Can I look at that? That's very complicated.
Yep. It has 2 jets, it has a power valve, it has a baffle, it's got its gaskets.
Wow, that's amazing.
And you can see here some of the detail of the passages, the brass restrictors for idle feed.
That's a little bit different than what we did.
That's better than your carburetor.
Yeah.
So this assembly will get mated to this one to create a main body and fuel bowl assembly.
So I have Venturi here.
Yep.
I got the body here.
Yep.
I got the bowl here.
Correct.
And I have a brain here, which I didn't have.
Correct.
Okay.
You
Got it.
basically used a tube and an adjustment needle to create the brain.
Okay. Got it. Understood. Interesting.
Okay.
So how much engineering effort and human lifespan does this represent? Like, we learned all this the hard way, right?
Yeah, I mean, you know, carburetors have been around since the turn of the century, but they have evolved immensely over the years. Racing engines have changed. They've gotten bigger, higher performance. You know, you want tighter air-fuel ratios. So the carburetor is a never-ending evolution, even today.
That's amazing. Okay.
Okay.
Gotcha. So you're thinking very hard about where to put this back so you don't
Yeah,
mess
I
them
want to
up.
make sure I don't screw him up. So I'm going to give you that back.
Got it.
Okay.
So that was the bowl. I didn't see a float. Is there float already in there?
I can show you that here.
He knew exactly what I was looking for.
Yep, he's on it. This isn't his first tour, I bet.
You've done this quite a bit, huh? All right.
So this is a fuel bowl assembly. It has a sight window in the side, and the fuel level in the fuel bowl, just like your visible carburetor, actually shows on the side of this. This is the float assembly. This is where the fuel comes in through this fitting, up in through this passage.
So you can actually see if the float is stuck.
Correct.
Is that what?
Sight glass, that's wonderful. That's great.
Did you ever have those on your?
Not me. No.
Yeah.
So the float moves up and down with the fuel level, and when it reaches the proper fuel level, it will seal off and not let any more fuel come in.
Where's the needle?
The needle is back in behind here underneath this nut and screw.
Can you adjust the needle here?
Yes, you can. So this particular, one of the benefits of a Holley carburetor is you can adjust the float level externally.
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 That's hard to do.
Yep.
That's hard to do.
And you
'cause-
can see it in the window just like your visible carburetor.
Well, yeah, that's amazing. Well, are you adjusting the float level or are you adjusting the relationship between the needle and the float?
You're really adjusting the needle, the relationship between the needle and the float, which as a result adjusts the fuel level.
Okay, that makes sense.
Now, one other thing I'll show you on this, we talked about the intermediate circuit and the transition circuit.
Right.
This is a little diaphragm in here that's called an accelerator pump. When you step down on that throttle, it pushes down on this lever.
Show me. One more time, please.
When you push down on this lever, it actuates a little diaphragm in here and it squirts the fuel through the squirter that we saw being installed earlier.
Like a water gun?
Like a water gun.
Really?
Yep.
So there's a mechanical pressurant.
Correct.
Okay, got it. Can I just pause and look at how beautiful it is that this is what?
Sure.
Can I see that? That's.
Yep. So all those screws are torqued automatically.
So this is coming along here.
Yep.
So she's feeding parts this way, he's feeding parts this way.
That's correct. So there's separate lines that are feeding him and these other assembly lines down through here.
So he's a critical point.
He is.
Okay, you're smirking. What are you smirking about?
He's good.
Is this, you were producing this part and you're transitioning to this?
Correct. So they've been making, these carburetors all morning long. Now they're transitioning to 2 barrels. Line never stops. It just transitions into the next queue. How long have you been here now, Benji?
15 years. 15 years. That's awesome. You like working here?
Yeah, it's good.
It's a good place?
My dad's been here for 52.
Your dad?
Yeah. My dad's been over there next year.
The Blue Shirt.
Been 52 years.
52. Your dad's been here 52. You've been here 15. What do you drive, Benji?
2007 Trailblazer SS.
Yeah? Is it stock?
No.
He's not even going to get into it.
No.
No, it's not stock. What are you doing right now?
I'm putting on the throttle body gasket.
Throttle body gasket.
Yeah, putting the screws in, putting the rubbers on, tighten them up, set the pumps and all that. And that's all I do.
What are you waiting on? You waiting on that part?
That one right there.
So you're ahead of production right now.
Yeah.
That's where you want to be?
Yeah.
Okay. So as soon as it gets to you, you're going to execute. You're going to be looking at the next thing. What are you doing there?
Setting the pump.
So you had it, you moved it until it closed, and then you bent all those tabs till they touched.
Yeah.
That's awesome. So he's grabbing it up here. What'd you say?
Is that the automatic choke? He said yes.
He's
It's
putting the choke mechanism on. So I talked about that thermostatic spring. There it is.
That's a bimetallic strip.
It's a bimetallic strip you put power and ground into, and then it heats this spring. Depending on the ambient temperature outside and how long the key's been on, it will change the choke flap.
Did you just tell me there's a heated bimetallic strip? You're electrically heating the bimetallic strip.
Yeah.
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 Shoot. This is too much.
And this is a vintage muscle car carb. So this is probably a 3.2 for a big block Chevy. If it was a Mopar,
454?
a 427.
Okay.
Yeah, so this would be like a 65 Corvette carburetor. We produced these when they were new, and we still produce them today.
That's amazing. How long has Holley been here?
Since 1952.
Wow. So these are packaged, ready to go?
Yeah, but there's one more step I got to show you.
Okay. How y'all doing?
Good morning. So the carburetors come down the main assembly line. The last step before they go in the box is a quality check. One of the things that differentiates Holley from everybody else is we actually wet flow test every single carburetor.
With gasoline?
With mineral spirit.
Okay.
So it has the same specific gravity without all the flammability concerns, but every carburetor actually is filled with fuel with mineral spirit, run through the process, flow tested 100% to ensure that all the settings pass.
Wow. So Monita is testing the carburetors as they come off the line. There's a machine behind me that I'm not allowed to show you, but I can blur it.
Yes.
Okay, so it's a machine where they actually test every carburetor, correct?
Yes, correct.
So what are you doing?
Well, right now I preset idle needle. I preset idle needle, and I know how much I'm supposed to open.
You know exactly how much to adjust it.
Yes, I mean close enough.
Yeah.
Almost.
So you open it, then close it.
Yes.
Okay.
I close all the way down, then I open right now 3/4. Then see, I close all the way down, then I open like 3/4. And now I'm gonna try testing.
Okay. Here's the blurry part. I'm enjoying it. You don't get to see it.
And now I have to finish this one first.
So this one's finished.
Yes, this the fast test, and then now I have preset the fast idle.
Yes.
That's what it's called, fast idle.
So you got your data, and then you're making an adjustment.
Yes, adjustment like for gauge the plate. Look, it have to be 29 on this model.
Yes.
So I have to add a little bit more. It's like smooth and easy. I have to gauge.
So briefly explain what a go, no-go gauge is.
A go, no go, make sure you're not undersized and you're not oversized.
Yes.
If the go gauge goes in there, you're large enough, but if the no-go gauge goes in there, you're too large.
And that's what you're doing?
Yes, that's what I'm doing.
Okay.
And after that, I make sure I drain fuel, like draining all the way out of how they.
I'm just gonna look at my face for a minute. Basically, she's draining the fuel off the device. Okay, that was a good one. So this is not tested, this is tested.
This is already
Okay,
tested.
so here we go, check this out. I can describe what I'm seeing. There's a lot of...
Now I'm testing computer, they're working, and waiting for wide open.
Yeah.
When wide open fast, now I can.
Oh, wow, I see. So she's testing different flow rates in different ways. We're making sure we're getting different pressures. Okay, if I understand correctly, you're literally running liquid through it and running fuel through it, and you're testing the pressures and you're getting real-time feedback on how it's doing.
Correct, and we're drawing a vacuum on it.
Right,
So it's simulating an engine running.
that's cool. How long have you been able to do that?
As far as I know, since the 50s when this facility was set up.
Pretty rad. Last step.
How are you today?
How are you doing? Good. Yeah, doing good? Busy. Busy, that's good. So this is foam, right?
Got to get the box closed before it blows up.
All right, I don't know if you caught that. I want to show that again. That was really, really cool. This machine has a bag in it, and it's got chemicals. I don't know where they are. There's chemicals either in the bag or something like that, and when he brings it out, it mixes those chemicals together, and it's like that spray foam insulation, and it stays in the bag, and he throws it in the box, and it forms around the part. Let's watch him do it one more time. That was pretty cool. So he's putting that in there. So that's putting the foam in and squishing it. And then it starts growing, right? It's like baking bread that's growing really fast. Thank you. Thank you for your time.
If you don't put it underneath that roller, it will blow the box out and pop the top up.
Oh, so that's literally holding it together.
It is.
So this right here is holding the box together.
Yep.
So when you open the box, it's custom formed.
Right.
That's so cool. It's
Feel the top of the box too. You can feel some heat in them.
oh, it's warm. Yeah,
It's very warm.
it's an exothermic reaction.
It is.
Surely you haven't always done that. That's like a finishing touch kind of thing.
They've done that for the 20 years that I've been here. Before that, they used various cardboard and other structures in there to hold it in place.
That's the quickest and cheapest way to do it.
That's the best way. It's the safest for the product.
So you do this all day, every day? That's a lot of carburetors, dude.
I don't. He usually does. I'm helping him out.
So where's he going?
So he's going to basically to the back dock. He will load it on a truck at that point, and it will go over to our distribution center, which is about 3 or 4 miles away.
That's a lot of carburetors, dude.
It's a lot of carburetors.
So people are still putting carburetors on cars.
Every single day.
Why?
In all honesty, they're a very simple device. People know how to work on them. They know what to do with them. They're comfortable with them. They're affordable, and people like them.
Yeah, because they feel like a muscle car.
They are, yes, exactly. And you know, you can fix them anywhere. You know, side of the road, something happens, you can get parts readily available, and you can make it, you know, make it go again.
I love manufacturing. Now that you know how carburetors are made, check this out. You remember the metering block between the bowl and the throttle body here? Well, I didn't know this, but it actually gets input from way over here on the base plate. There's a little slot down here. This blew my mind. And as you operate the throttle here, look at that. That little slot opens up gradually, and the size of that slot precisely controls the airflow that's going to the metering block that changes between all the different circuits. It's like a precise dance between pneumatics and fluid dynamics. It's an analog computer. This is incredible, and that is just another reason why I think carburetors are amazing. You've got something in your ear. Or you should have something in your ear. I'm just joking. But this is sponsored by Raycon. These are the everyday earbuds, and you'll notice that when I open the box, they're not in there because they're in my pocket. That's 2 magic tricks in a row. Let me show you what these things are. These are the everyday earbuds. They're amazing. You get over 32 hours of battery life and 6 hours of playtime. The way it works is you charge up this little pill. This is a USB-C connector. Isn't that nice? And the pill itself charges up the earbuds. I have run over 300 miles wearing these things this year, and they are amazing. They do not fall out of your ear. Every set of Everydays comes with a customizable gel set of ear hole adapters. Ooh, look at those. Oh, what is this? We even got some lanyard action. Oh, look at that. These things are like half the cost of other premium wireless earbud brands and sound just as amazing. Let me do a little yeah! So one thing I love about these things is how seamlessly they connect with my phone. You can see not connected right here. If I can open this with one hand, you can see as soon as I get that open, watch it right there. And boom, connected. You see that? Long story short, you're smart. You can tell if people are telling you the truth. I'm telling you the truth. I use these everyday earbuds by Raycon all the time. You will love them. If you want them, go to buyraycon.com/smarter. That gets you 15% off. You're gonna love these things. Pick out whatever color you want. I like the blue ones, and I like the white ones. I don't think you'll need it, but Raycon has a 45-day free return policy. Every time you put them in your ear, you hear Raycon power on. If you have these things, you're gonna know exactly what I'm talking about. Check it out. buyraycon.com/smarter. It gets you 15% off. Thank you for supporting the sponsor that supports Smarter Every Day. Holy cow, was that a fun video. I hope you enjoyed it. I learned a ton. Thank you to Holley, thank you to Dad. How awesome is it that you guys let me make videos about carburetors with my dad? I just want to say thank you. I'm grateful that you let me do that. I cannot thank you enough. Thank you to everyone who supports on Patreon and lets me do crazy stuff like this. I have more ideas cooking, and it's really, really interesting. The next step, obviously, after carburetors, fuel injection. It's complicated. So if you're interested in that, please consider subscribing to Smarter Every Day. That video is coming up as soon as I can get that thing out. I think you'll really enjoy it. Anyway, I'm grateful. Thank you to the patrons. Thank you for considering subscribing. I'm Destin. You're getting smarter every day. Have a good one.